Alright, so here is my video for the closure problems. The video is going to cover problems 130 to 133. So the first half of the problems I'm going to do as a video lesson, and the second half of the problems are going to be the homework. So 134 to 138 are the ones that you're going to have to do in Kami and turn back into me. 130 to 133 is the in-class work. And an important closure here, since we did have a break in the middle of chapter 8, this is a nice way to review a lot of the stuff we were doing throughout the chapter. And in 134 to 138, there are some challenging problems that recap some of the previous stuff we were doing too, so I thought it would be good to assign it for homework and see what we're able to do. And with this being online, I can actually go in and see how we're doing with the homework. And maybe I can post a video for those 4 problems too, if we need it. But let's, for the sake of time, get started with problem 130. So 8-130 says Miss Frank loves the clock in her classroom because it has the school colors, green and purple. The shape of the clock is a regular dodecagon. Dodecagon is a 12-sided shape. That'll be important, with a radius of 14 centimeters. Centered on the clock's face is a green circle with a radius of 9 centimeters. So the whole shape is a dodecagon with radius 14 centimeters. That little circle in the middle is just a circle with radius 9 centimeters. If the region outside the circle is purple, which color has more area? And so it's saying, is that shaded part more area, or is that white part more area? And they say the shaded part is purple and the white part is green. And so we're going to figure out, does the shaded part have more area, or does the unshaded part have more area? The first thing we're going to do here is we're going to find the area of the dodecagon and find the area of the circle. So the dodecagon is going to be the circle, it's going to be the shaded and the unshaded together, while the circle is just going to be the unshaded part. I'm actually going to, because I have something on the bottom of this page, I'm just going to create a new page to do this work on. The clock from the previous page. And if we're going to find the area of this dodecagon, we got to follow our steps. We're going to have to first turn this into a triangle and find that central angle. Alright, well, central angle is always 360 divided by the number of sides. And 360 divided by 12 gives me 30. So I have this triangle now, and I'm going to redraw it. I have this triangle that has 30 as my central angle. I'm going to drop the apothem down to cut that in half. And so if I cut 30 in half, now I have an angle that is 15. Something I need to put in here too, I have my angle now, but I got to go back to my problem quick. It says that the shape of the clock is a dodecagon with radius 14, which means my radius, and I'll put it in red here, is from the center to one of the vertices. So that is the 14. Okay? And that line on my redrawn triangle is this one right here. Okay? So those are the sides that I have. I have the 15 angle, I have the X, and I have the Y. And just like I do in most of these problems, I got to find out what X is, so I have a base. I got to find out what Y is, so I have a height. So let's start by finding X. We have a X, so our angle is the 15, so across from our angle is the X, which means it's opposite. The apothem always creates a 90, and across from the 90 is the 14. So this is an opposite hypotenuse problem, which means it's a sine problem. And so the sine of 15 equals the opposite, which is X, over the hypotenuse, which is 14. I put my sine over 1, and I cross multiply and solve here. Alright, 1 times X. 1 times X gives me X. The sine of 15 times 14, I gotta use my calculator here, sine of 15 times 14 gives me 3.62. So that little portion, or half of the base, is 3.62. So I want the whole base, which means I have to multiply that by 2, and 3.62 times 2 gives me an entire base. The whole base down here is 7.24. So now I have the base of my triangle. All right. Now I got to find what that y is. Well, the y is between the angle and the 90. That's my adjacent. And I still am using the 14, which is my hypotenuse. And so adjacent hypotenuse tells me it's a cosine problem to find y. And so I get the cosine of 15 equals my adjacent, which is y, over my hypotenuse, which is 14. Same kind of thing I did before. I put the cosine of 15 over 1. I cross multiply here. 1 times y gives me y. The cosine of 15 times 14 gives me 13.52. All right, and so I now have a base of 7.24. I have a height of 13.52. I have everything I need to find the area of that one triangle. And like I said in the problem, this is a dodecagon, a 12-sided. This is 12-sided. And so if I find the area of one triangle, I just need to multiply it by 12. So let's find the area of just the one. All right. An area of a triangle is 1/2 base times height. 1/2. The base was 7.24. And the height is 13.52. If I calculate this out, I get that this is 48.94 for one triangle. And like I said, this is a dodecagon, so it's 12 triangles. I multiply this by 12. So 48.94 getting multiplied by 12. And that will give me that dodecagon has an area of 587.28 units squared. Did they give me a unit? Let's check. Centimeters. Centimeters squared. So this is 587 centimeters squared. Now, even though this is a really useful piece of information, it's really not applying to my problem yet, because the problem is, what's the area of the shaded part and the unshaded part? And I found the area of the shaded plus the unshaded right now. I found the area of this entire shape. And so what I'm going to do next is I'm going to find the area of just this circle, just the unshaded circle right now. So then what I can do is I can take the area of my total area, subtract out the unshaded, and I'll be left with the shaded part. And so we're going to get one step closer with this next step of being, let's find the area of that circle. Okay, oop, I don't want that. So this is an important piece of information right now, but let's keep going. So the area of a circle is equal to pi times the radius squared. And if I go back to my problem, it tells me that I have a radius of 9 centimeters. So now I can just plug in, and I get the area of that circle is equal to pi times 9 squared, which equals 81 pi, which, let's put that into decimal form. 81 times pi gives me 254.47 centimeters squared. Okay, so now I have the area of my total shape, my whole clock. This is the total. I have the area of the circle, which I'm going to call, because what do they say? They call it a green circle, so I'm going to call that my green area. So if I get down here, the 254.47, that's my green area. If I want to find my purple area, right? Is it purple? Yeah. If I want to find my purple area, what I have to do, I have to take my total area, I have to subtract out the green area, and I'm going to be left with just purple. And then that'll answer my question of what's more, the green area or purple area. All right, so we got only like one step to go here, and we can do that. My total area, 587.28. So 587.2. Sorry for my eights. I am still bad at writing them on here. 0.28. So my total area minus my green area, 254.47. That'll give me my purple area. So I gotta use my calculator here. 587.28 minus 254.47. That gives me an area of 332.81 centimeters squared, and that's for purple. And so if I'm evaluating this clock, and it's a great problem, we had so many area parts and so many kind of a composite shape actually. But if I evaluated at the end, the question was asking which color has more area. Well, the green had an area of 254 centimeters squared, and the purple had 332.81 centimeters squared, and so the purple area was more, or what I would say, because we don't have color here, the shaded area was more than the unshaded area. All right, like I said, a great problem, finding the area of a polygon in there, finding the area of a circle, and then working with the composite shape. Let's move on to 131 to hopefully get that done in this video, and then hopefully we only have one more video for the last two problems. This is a graphing problem. I have the graph paper on here so we can get started. Things to remember is that our coordinates are always x and x comma y. X controls left or right. If it's negative, it goes left. If it's positive, it goes right. For y controls up and down. If it's positive, it goes up. If it's negative, it goes down. And we can start plotting those. And so let's plot A. -2, a +6. And so I go over 2 to the left because it was negative. +6 for y means I go up 6. 1, 2, 3, 4, 5, 6. My A point is right there. I call that point A. All right. Point B here is at 2, 3, so a +2, a +3, which means I go to the right 2 and up 3, 1, 2, 3, and that is my point B. Okay, point C is at +2, -2, so I go over 2, down to here, and that is my point C. And lastly, my point D at -2, 1, I go over 2 to the left because it's negative, and is it -2, -1? No, -2, +1. So I go -2 to the left, +1 up. Oop, that's a bad one. +1 up to here, and that is my point D. And now I can create my shape using straight lines. And I get, there's that, and I get my shape right here. All right, I can start kind of evaluating it as it is right now. It's saying for part A, what is the most descriptive name for this quadrilateral? Well, I don't really know yet, and I only have a minute left in this video, so I'll continue this problem and the next problems in the next video. But just looking at this quickly, I can kind of see like this has got the shape of a rhombus or a parallelogram. But when we do these problems, we have to be really sure of what it is. So we're going to have to evaluate the slopes to see, are these lines really parallel? And we're going to have to evaluate the side lengths because if it's a rhombus, it should have all equal side lengths. But we'll do that in the next video, so stay tuned. I know you can't wait.